Good morning, guys. Mr. Milton here. Today we're going to talk about distance in midpoint. After this video, you should be able to use the distance formula to find the length of a segment on the coordinate plane, and you should be able to use the midpoint formula to find the coordinates of a midpoint of a segment. Alright, in lesson 3 we found the length of a segment using segment addition postulate. Okay, what happens if my segment is on the coordinate plane? Let's find out. In this example we have, they want us to find AB. Find the exact length of AB and then round your answer to the nearest tenth if necessary. Alright, so looking at this, it's a little bit different than just finding the segment. And the reason is we don't have any information to do it. It's on a coordinate plane as well. Okay, so we need another way to find length. And we can do this using the distance formula. And here's the distance formula. Distance formula will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, now this is pretty long, but I will show you how the distance formula is the Pythagorean theorem. Forgot what the Pythagorean theorem is. A squared plus b squared equals c squared. Okay, I'll show you how the distance formula is Pythagorean's theorem. I'm going to derive it, but you won't be tested on this. But it's kind of nice to see what it is and how you could use it. Okay, so first things first, I'm going to show you using the distance formula, finding the distance of this. So what we have is we have 2 points. We have A, which is negative 3, 4, and we have B, which is 2, negative 3. Alright, if we plug these into the distance formula, what we get is x coordinate, negative 3 minus 2 squared plus y2, oops, I did that backwards, but I'll make sure I keep the same thing, 4 minus negative 3 squared. Okay, so I actually called A 0.2 and B 0.1. Doesn't really matter which way I put it. Alright, so negative 3 minus 2, that's negative 5 squared. 4 minus negative 3 is positive 7 squared. Okay, 25, negative 5 squared, plus 49. Add those together, that gives me 74. Square root of 74. What is 74 divided by 2 is 37. That doesn't break down anymore. So the exact length would be radical 37. This is exact. When they say exact, they just mean how you'd find it in a radical. Okay. Rounded to the nearest tenth, I can do that pretty quickly. 74 square root of that would be 8.6. Okay, 8.6 to the nearest tenth. Okay. Now, that's using the distance formula. Doesn't have to be too bad, but it is kind of long. Pythagorean's theorem is a little bit easier. And what Pythagorean's theorem does is basically it takes the distance formula and it dumbs it down or simplifies it. I guess I'll say simplifies it more than dumbs it down because simple is better. Dumb isn't. Simple is better. So here we go. What we can do is we can say, okay, what is the distance, what's the vertical distance between the 2 points? That's really what y2 minus y1 is asking. What's the vertical distance between the 2 points? We saw that in our formula was 7. Here's an easy way to see that. 1, 2, 3, 4, 5, 6, 7. This length is 7. What's the horizontal distance between our 2 points? Okay, we saw that in our formula was 5. I know it says negative 5, but remember distance can't be negative anyway. That's why we squared. So we saw that was 5. Let's see if it says the same thing here. 1, 2, 3, 4, 5. It does. And so now instead of using, the formula, we could have this right triangle of 7 and 5. And use Pythagorean's theorem to find this side that we're missing. 7 squared plus 5 squared equals x squared. 49 plus 25 equals x squared. X squared equals 74. And then to find x, take the square root of both sides, and x is the square root of 74, not 75. Okay, same thing that we found. Use my little squigglies because it's about 8.6 because we rounded it. Same thing that we found. So, the exact length of AB is radical 74. Rounded to the nearest tenth, 8.6. Okay, Pythagorean theorem, distance formula, really the same thing. And Pythagorean theorem is a little bit easier to remember. Okay, so let's find the length of RT if the coordinates are -2, -1, and -8, 7. Something different. So I'm at -2, -1, -2, -1. I'll label that point R. I'm at -8. Nope, can't do it up here because I don't have -8. So I will do it with the distance formula. So I am going to use this right here. Let's switch back to a pen since I'm using the same thing. So since I'm using these, I have x2, which is -8, minus x1, so minus -2. I'm going to change it to plus. When I minus the negative, it's plus. Plus y2, which is 7, minus y1. So minus -1 or plus 1 squared. So -8 plus 2 is -6 squared. 7 plus 1 is 8 squared. So I have 36 plus 64, which gives me 100. Radical 100 is 10. So I know that the length of RT equals 10. Okay, again, -8 plus 2 is -6. 7 plus 1 is 8. -6 squared is 36. Keep that in parentheses so it actually works. 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10. Okay. To midpoint on the back. It can be helpful to find the middle of something. For example, if Billy got 60% on his first quiz and a 90% on the second quiz, the middle, not he middle, the middle, or average quiz score would be 60 plus 90 divided by 2. 150 divided by 2, which is 75. We can do the same thing with segments on the coordinate plane. It is essentially finding the middle or average of the coordinates. The midpoint formula looks like this. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Notice that the answer for finding a length is a number, while with the midpoint the answer is given as a coordinate. Midpoint is a location. We're saying where is it at. So we're given this segment, and they want us to find the midpoint. Going to be important for us to be able to label these points. So -1, -2, -3, -1, -2, -3. So this first point's at -3, -3. 1, 2. 1, 2, 3, 4, 5. 2, 5. And so now to find the average, what I'm going to do is I'm going to take the average of the x's. So 2 minus 3, or 2 plus -3 over 2. And 5 minus 3, or 5 plus -3 over 2. So 2 minus 3 is -1. -1 divided by 2. And then 5 minus 3 is 2 over 2. And so here are my coordinates. I'm just going to say negative 1/2, comma, 1. There's my answer. Okay. Let's look at another type of problem we'll see with midpoints. It says QS has endpoints Q 3, 5 and S 7, 9. Find the midpoint of QS, call it M, and then find QM to the nearest 10. Whoa, that's a big problem. So, we have QS at 3, 5. We could plot those points if we want to, but I will not. So we're finding the midpoint. So I'm going to say, okay, what's the average of the x's? 3 plus 7 divided by 2. What's the average of the y's? It would be 5 minus 9 divided by 2. So that's 10 divided by 2, comma, negative 4 divided by 2. And that's 5, negative 2. That's the midpoint, point M. Now there are a couple ways that we can find the length of QM. Okay, we know that M is the midpoint. So we could find the length of this whole thing and divide it by 2, and that should give us what that length is. Or we could use the midpoint, either way. Alright, so here we go. What I'm going to do is I'm going to plot these so I don't have to use the distance formula. I'm just going to kind of do it on my own sketch. So I'm at 3, 5, 1, 2, 3, 1, 2, 3, 4, 5 for point Q. I'm going to do 5, negative 2 for point M. So 4, 5, negative 2. Okay. So 5, negative 2, 3, 5. Okay. Now I'm going to say, how far over do I have to go? I have to go over 2. From 3 to 5 is 2. How far down do I have to go? From 5 to negative 2? 7. So I'm going to say, okay, 2 squared plus 7 squared should give me this length squared. Just call it x again. So 4 plus 49 equals x squared. 53 equals x squared. And to the nearest 10th, I can find that taking the square root. Square root of 53. 7.3. Alright. This last problem proves to be pretty difficult, mostly because it asks the same questions in a different way. Okay, so it says the midpoint of Kn is 3, 4. One of the endpoints, K, has a coordinate negative 3, negative 2. Find the coordinate of N. I always like to see what they're talking about in these problems. So what they did was they told us that we have one point. Actually, I'll give a coordinate here. Coordinate plane. So they told us that our midpoint is at 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay, that's our midpoint. I'm just going to call it M, so I know it's our midpoint. Okay, and then it told us that we have the endpoint K at negative 3, negative 2. 1, 2, 3, 1, 2. K's here. In negative 3, negative 2. Now what most people trip up on this problem is that they want to find something in the middle because they saw the word midpoint or they know we're using the midpoint formula. They're not paying too much attention. But really, we don't need to find anything in the middle because they already gave us the middle. We need to find the other edge. Okay, and so in order to find the other edge, we have to think, okay, this is from endpoint to middle. The other edge should be somewhere up here. There's two ways that we can do this. We could say, okay, well, how far did they count over and count up? Okay, but the reason that I don't want to promote that way is that we could use really big numbers, okay, which would make it difficult. For the midpoint formula, it's not too tough to remember, so I just like to plug in what I know. I know the midpoint of the x's, is 3. So So I'll say 3 equals, 3 is the average of the two x coordinates. I have negative 3 plus something I don't know, I'll just call it x, over 2. And I'll do the same thing for the y's. 4 equals negative 2 plus something I don't know, I'll just call it y, over 2. And now I'll solve these two problems. Multiply both sides by 2. 6 equals negative 3 plus x. Add 3 both sides. 9 equals x. Do the same thing for y. Okay, cancels that out. Like 8 equals negative 2 plus y. Add 2. 10 equals y. Okay, now remember, I'm not going to say x equals 9, y equals 10. The answer should be a coordinate. So my answer is 9, 10. And that makes sense because we know that this line should be somewhere up here. Okay, 9, 10. Makes sense there. Alright, so that's the midpoint formula. That's the distance formula. Hopefully you know how to use those. You know how to use the Pythagorean theorem instead of the distance formula as well if necessary. And you know how to find the midpoint and the other endpoint given the midpoint. Alright, see ya.